application of fold, or you can say mechanism of fold. So fold mechanism can be expressed in two ways: on the basis of applied force direction, on the basis of layered properties. So on the basis of applied force direction, it is of three types: one is buckling, bending, and passive folding. So buckling, bending, and passive folding. And on the basis of layer property, we have orthogonal flexure or flexure folding, another is flexure slip folding. Applied state direction, buckling when forces are applied parallel to the layer. Forces are applied parallel to the layer. Or buckling, in one sentence we can say layered parallel shortening, a layered parallel compression. Layered parallel compression of the buckling. Bending, in where the forces applied at a higher angle or perpendicular to the layer, or you can say in the transverse direction of the layer. The transverse direction of the layer in the bending. Passive folding, in case of passive folding, forces are not directly upon the folded layers. Forces are not acted directly upon the folded layer. That's why it is called as a passive folding. And buckling is called as a active folding. Bending is also a type of passive folding. So any type of fold that produces by force applied parallel to the layer, that is your active. So buckling, what are the different conditions are required for the buckling? So first, one more thing, for buckling you will require competitive contrast between the layers. So there must be different density or different viscosity of layers present. And the two condition, another is your surface irregularities. There must be surface irregularities. So contrast viscosity, this for buckling, viscosity, contrast, these are the required condition. Then surface irregularities. Surface irregularities. So these are two conditions for the formation of active folding during the buckling. So during the folding, only the competent layer they get folded. So these are competent layer. The black one is incompetent. So when these anisotropic layers of rock get folded, only the competent one will get folded. When the competent one get folded, then the incompetent will take the shape of a fold. As for folding, we always require competency. And folding occur in plastic rock, like in ductile condition, or you can say in plastic condition. So if it is a pure buccal fold, then it can produce class 1B fold, or the competent layer will produce class 1B fold, and the incompetent layer produce class 3 or class 1A fold. So these are the characteristic of active folding is also we'll study more in more of flexure folding. What are the other characteristic of a buckling fold? Fold, see, completely fold only in the sense part only these layers are affected by force. Like they are getting folded. In between these layers, they will also take the shape of the fold. Shape of the fold means also they are fold. So we can define them as class 3 or class 1F. Then comes to passive folding. So the passive folding, it is the type of fold where force, it is not directly acted upon the folded layer. It is not directly acted upon the folded layer. It is like this. Suppose you can take the example like this. Suppose there is a rock layer here. So if you compress the rock layer, it will get shortened, but the linear structure in it will get folded. So the force is applied on the rock, it will get shortened. The result will be the folding of this linear structure. Or you can also apply this type of stress, it will also get folded. So this is where the force is not directly acted upon the layer. So these are only used as a visual expression of strain. See how the strain changes after the force. So this is called as your passive folding. So that is called layer exert no mechanical influence on the folding. Huh? So the direct force is not applied. So it is served as only visual expression of strain. No mechanical or competency contrast is required here. Required any competency contrast, surface irregularities, all other thing that is required in case of active folding. It is not a required condition in case of passive folding. So if it is a perfectly plastic fold, passive fold, then it can produce class 2 fold. The similar fold produced by passive folding. Also, passive folding produces harmonic fold. Passive folds are frequently found in more of softer regions, like Melanolitic zone, Doctilitic zone more, particularly in monomineralic rock, quartzite marble. In this part, you will find passive folding.